Okay, so the last thing to talk about in section 9.3 is what is called the power of a test. Okay, so let's start with what is the power of a test. I'm going to start out with the basics of it and then get us down to how it's actually calculated. Power is the probability of avoiding a type 2 error if we're avoiding something, it's the complement. So the way that this is practically calculated is it is 1 subtract the probability of a type 2 error. Sometimes a type 2 error is denoted as beta. Alpha is type 1, type 2 is sometimes denoted as beta, so you can also write this as 1 subtract beta. Okay, here is practically what we care about with power, like the meaning. If we're taking away a type 2 error, we're starting with 1, we're taking away the probability of an error. So really what this is, it is the probability of rejecting the null, so finding significant evidence to reject the null when our parameter is equal to some other value. So we want a high power. We want to avoid a type 2 error. We want to be able to correctly reject the null when we need to. Okay, so let's take a look at an example. A drug manufacturer has developed a new cholesterol-reducing medication that they think is better than its current drug. To test it, they recruit 100 volunteers and randomly assign half to the new drug and half to the old drug. When the experiment is over, they will conduct a significance test to determine if there is convincing evidence that the new drug is better than the old drug. So part A is just review, describing a type 1 and a type 2 error. In order to do that, of course, we need to know what our null and our alternative are. Now, this doesn't tell us if we're looking at mean or proportion or anything like that, so these are just going to be in general terms. We want to know, is there evidence that the new drug is better than the current drug? So our alternative will be that the new is better than the old. Our null then will be that the new is equal to the old. Has to be equal. Okay, so if we think of type 1 and type 2 error, what I'm going to put in green is what I write down to help me process, but it's not actually the answer. We've said I start with type 2. Type 2, we failed to reject the null. What makes it an error, though, is that the null was false. Type 1, we reject the null. What makes it an error is that the null was true. When we put this in context, though, it has to be in terms of HA. So when I say reject the null, that is about HA. Rejecting the null means I found evidence for HA. So a type 1 error would be we find sufficient evidence that the new drug is better than the old. It's actually current drug. The new drug is better than the current drug. Is that enough? Have we described an error? No, we've described a decision. So we find sufficient evidence that the new drug is better than the current drug when this is not true. If we fail to reject the null, we do not find enough evidence for the alternative. So type 2 error, we do not find sufficient evidence to believe the new drug is better than the current. Again, that's a decision. That's not an error yet. All we're saying is we've found evidence. So we haven't described an error. So we do not find sufficient evidence to believe the new drug is better than the current, even though it is. Okay, that's the stuff we've already done, type 1 and type 2 error. Describing the power of the test. Power of the test is always related to type 2 error, which means we know the null is false. So the power of the test is going to be what happens when the null is false. Well, if the null is false, we should be rejecting the null. So if we want to describe the power of the test in this context would be finding sufficient evidence that the new drug is better than the current. So we find sufficient evidence that the new drug is better than the current, and we reject the null. That is the power of the test. Okay, so that's the first thing that you have to be able to do is tell me what power means in context. The second thing you have to be able to do is talk about how to increase power. So what can the manufacturer do to increase the power of the test? First thing for you to notice or to know is that power calculations are hypothetical. And they are done before the study. It is similar to calculating a sample size. For a margin of error. Because as we've talked about, type 1 and type 2 errors are also theoretical. We don't know the true value of the parameter. If we did, we wouldn't be carrying out a hypothesis test. Okay, there are 3 factors that affect power, 2 of which are the most practical. The first one is a bigger sample. And the why behind that is if you have more data, you are more likely to make the correct decision. Okay. Second one is a bigger significance level. So a bigger alpha. If you have a bigger alpha, it is easier to declare that evidence is convincing. So those are the 2 that are most practical. Take a bigger sample or make your alpha bigger. The last one that I'm going to write down does affect power, but it is not a practical choice. The last one is to make the new drug even better. What that means in general is make a bigger difference between the true value and the null. Now, that's not practical because we don't know the true value. All we know is the null. So that's why I say that one is not practical. We okay? Okay, 2 more things to talk about, and then you guys are going to do an example. One thing you may have read about or we've talked about a little bit is the difference between what is called statistical significance and then what is called practical significance. When we say statistical significance, what we mean is that we reject the null. When we talk about practical significance, that means, do we actually care? Okay, so here is an example to think about. Let's say that you are someone who has a company that has a vending machine in it. And that vending machine only has cans of soda. And those cans are supposed to have 12 ounces of soda in them. Or maybe you don't have a vending machine. You're making these cans of soda. So you're making cans of soda that have 12 ounces. If the cans of soda have less than 12 ounces, it's not enough soda. If they have more than 12, that could damage the can. They could explode, things like that. And so you want to know, you would do a test. Sorry, this is HA. To find out, is there evidence that the mean amount filled is not 12 ounces, that it's too little or too much? If you reject the null, that would be statistical significance. So that would mean there's evidence that those cans are being underfilled or overfilled in general. Now, the question is, by how much? If you are the person who's producing these cans of soda, and they're supposed to have 12 ounces, but they actually have 11.99. Do you care? 11.99 ounces. Probably not, right? That is a case of statistical significance because we rejected the null, but practically it doesn't really matter to us because it's so close. Now, on the other hand, if the cans were actually getting filled with 10 ounces of soda, that's a pretty big difference. So that's one where we rejected the null, and also it's a big difference, and we're going to step in. So practically, if you're a statistician, what happens is if you carry out a test and you reject the null, the very next thing that's done is a confidence interval to see where do we think the true value is. And that's when someone will decide, does this matter or not? Okay, last thing before the example is, what is the problem of multiple tests? If we have more tests, there's going to be bigger error. So every time you do another test, it just adds on the possibility of more error. Okay, those are the big things that I needed us to do. We are going to do some examples, though. Well, one example that you're going to do together. Questions for me before you look at the example? Okay, go to the next page. We're going to start it together. In the potato example, we have an inspector that is testing P equals 0.08 versus P is greater than 0.08 with a random sample of 500 potatoes. P is the true proportion of blemished potatoes. Suppose that the true proportion of blemished potatoes is P is equal to 0.1. So we're taking a sample of 500 potatoes, just looking at what proportion of those potatoes have a blemish of some kind. Okay, I'm going to do A with you, and then you're going to work in your group on the rest of this. What is the correct decision in this case? Oliver? Decisions being reject or fail to reject? Reject. Okay, so the correct decision in this case is reject the null, and that is because the value of p, which is 0.1, is in fact greater than 0.08. Okay, at this point, what I want is you are going to take 8 to 10 minutes to do as much of this as you can with your group. Part E, you really haven't talked about, so we'll go over that one. But I do want you to see what you can do with the rest of this. Okay, so I'm going to show you my answer key. So for B, are we going to find convincing evidence? If we are rejecting the null, and we know the null is false, when it says convincing evidence, it's asking, like I said, about power. When is power going to be highest? On the previous page, when we wrote down those 3 factors, if we increase the sample size, it increases power. If we increase alpha, it increases power. If we increase the difference between the true value and the null, it increases power. So if we take a bigger sample, we're going to have higher power. Because we talked about, you have more data, you're more likely to make the correct decision. The bigger alpha will give us a higher power. And that's because if we increase the likelihood of a type 1 error, it will decrease the likelihood of a type 2 error. And then power is 1 subtract type 2. In part D, the bigger difference will make us easier to see a difference. So if we are looking for a difference between 0.5 and 0.08, it's going to be much easier to find a difference between those two than it will be between 0.08 and 0.1. So then the last thing in E, well, not the last thing, but the thing in E we haven't talked about is another way to increase power. And we've talked about decreasing sampling variability, is to take a stratified sample. It's to take a stratified sample. Okay, so then in F, interpreting power, power is the probability of correctly rejecting the null. We reject the null if we find evidence for the alternative, significant evidence. So given the true proportion is 0.11, so given the null is false, there's a 0.76 probability of finding enough evidence, of getting a sample proportion big enough to reject the null and believe that the proportion is bigger than 0.08. And then lastly, power is 1 subtract a type 2 error, so the likelihood of a type 2 error in this case is 0.24. Okay, practically, what I need you to be able to do is B, C, and D. You need to be able to tell me how to increase power. And you need to know that power is 1 subtract beta, or 1 subtract type 2. Those are the things that are most important. So if I were to ask you, is power going to be higher for a sample size of 100 or a sample size of 50? You would need to be able to tell me 100. Bigger sample, higher power. Questions for me?